Hey everybody, welcome back to our Gradius tutorial here on Peppermint Learn. Now before we get started today on some of the advanced movement mechanics, I want to make a really quick change just to make our game look a little bit better. And for that we're going to go ahead to our directional light, like so. Go over here to our shadow tap drop down, and we're going to change that to say no shadows. And what that does is it just makes our game look a little bit nicer when we're in our game view. Just to compare, I'm going to go ahead and go over to our shadow tap again. I can see it's got that sort of shadowy point there, and it's casting a shadow on our quad. We don't want that to happen, so we're just going to go ahead and leave that at no shadows. Alright, now that we've done that, we're going to go ahead and hop back into our Visual Studio here, and what we're going to be doing is we're going to go ahead and sort of make this a little bit easier for Unity to read. So we're going to clean up our code quite a bit, and we're just going to go ahead and sort of shorten things down a bit. So we're going to do that is going to do a public rigid body rigid, like so. Rigid equals get component, rigid body, just like so. And then what this lets us do is it lets us replace all of these with just rigid. Just like so. Now that doesn't really make a difference to how it runs. It doesn't really make it run faster, slower, or anything like that. But it does make it look a little bit more professional and makes it a little bit easier to read. It also saves the time and effort whenever we're typing things out. We don't need to worry about typing every little detail out from here on down the line, which just makes things a little bit nicer for us. Now, the next thing I want to do with this is I want to adjust how far the player goes based off of where you click. And the way we do that is actually quite simple. We basically take the exact same thing we've got here, except we go ahead and we put that for the Y value as well. So what we're going to do is we're just going to get rid of that bit there. I'm going to go ahead and say inside of here, if hit dot point dot y is greater than transform dot position dot y, rigid dot add force vector 2 dot up times jump speed. And what that means is that if we click below our player, not just above a player but anywhere on the screen, it will detect and it will adjust where we move accordingly. So once that's compiled, we're going to go ahead and hop back into Unity, and we're just going to go ahead and test that out really quick just to make sure everything's working properly. And you should see that when I click above our player, like so, it jumps up. When we click below, all it does is it moves to this side. And that gives us a little bit more control over how our player moves around the screen. But we're going to take it a step further, and we're actually going to have our player move a percentage of the maximum jump based off of how close we click to the player. So if we click out the way over here, it's going to move further. If we click down here, it's going to move just a little bit. And what that's going to do is going to give the player a little bit more control over where the character goes. So the way we accomplish this is actually a little bit more complicated than just doing what we have right here. And we're going to hop into Visual Studio for this so I can demonstrate how we're going to type this out. So what we have right here is we've got our hit.point.y is greater than our transform.position.y. And so this is detecting, do we jump up when we click the button? And it's saying yes, we do. But what we actually want to do here is we want to do another value. And what we're going to put down here is if hit.point.y, yes, sorry, we're going to do rigid dot add force vector 2 dot up, just like we did previously, but we're actually going to do a little bit of something different here, and that is going to be doing 1 plus hit dot point dot y minus our transform dot position dot y, and we're just going to divide that by 10 so we get a percentage. So what that means is we'll have our jumping being, say, 1.1, 1.2% of our actual jump power, and that'll give us a little bit more control, like I previously stated. And then we're going to go ahead and take this, and we'll go ahead and do the exact same thing up in here. So we can do our lat speed times. This is a little bit different because we have to modify which one is which. So for this one, we're going to do transform dot position dot x minus hit dot point dot x divided by 10. And what this is doing here is we're just going to go ahead and close out our brackets like so. And this is because we don't want the player just lunging across the screen to the right or the left. We want them to have a little bit more control over those two directions. Whereas down here, our players are mostly going to be clicking when they get near the bottom of the screen, so we want them to be jumping up a little bit further, just to make things a little bit more playable for our players. And then what we're going to do down here is, apologies, hit dot point dot x. So the exact opposite of what we have right above it. 9 out of 10, and then close that off. Go ahead and save that out, and then once that compiles, we'll go ahead and test. And so now when we hit play, you're going to be able to see that when we just click a little bit closer to the player, he doesn't jump as far. He just sort of jumps a little bit to the right, or to the left, sorry. And then when we click away from it, it jumps a lot further. And this sort of means that it'll go where we want him to go. And for this, I'm actually going to go ahead and increase the mass of our player just a little bit heavier. That way he doesn't jump as high. So we're going to go ahead and, apologies, change that to, let's go ahead and just do 3.35. And now that we test it, we should have a nicely controlled player, just like so. Alright, so now while it's all very nice and dandy that we have our movement working, there's not really any point to movement unless we're either avoiding something or going towards something. So that's what we're going to go ahead and implement now. We're going to hop back to our scene view, like so, and we go ahead and right click, go to 3D object, create another cube, and we're going to go ahead and call this one our enemy. And then we're just going to go ahead and duplicate that, and we're just going to call this one our point up. And to help us differentiate between the two of them, we go ahead and go to our assets, materials, and we're going to create two new materials, going right click, create material. This is going to be our enemy material. I'm going to go ahead and make this one a bright red. And drag that onto our enemy like so. And then another material, this one called our point up material. And we're going to make this one bright green so we know we want to go towards that. And we're going to go ahead and drag that onto our point up. Just like so. And so now that we've done that, we're going to go ahead and introduce something called triggers. So we're going to go to our player prefab, which we're actually just going to go ahead and rename again. And go ahead and click something called isTrigger. And what this will allow us to do is that when this enters the red or the green, or anything else for that matter, Unity will detect that and will let us update what happens. And we're just going to go and hop into here really quickly, make sure everything is lined up correctly, and then hop back into 2D mode. And so what that allows us to do is that allows us to run functions such as giving us more points, ending the game, things like that. Speaking of, we're going to go ahead and shift select both the enemy and the point up prefabs. Go down to add component, and we're going to go ahead and make a new script called AI component. And then we're just going to click create and add, like always. And then once that compiles, you'll see it pop up here, just like so. We're going to go ahead and open it up. Before we get that working, however, we need to select our enemy and make sure that this is checked here in the script, thus telling us that it is in fact the enemy. Now when we hit play, we should see them moving to the left at 2 different speeds, as you can see here. Now that's all well and good to see, but we also want to have the game reload whenever you hit the enemy. So to get that working, we're going to hop back into Visual Studio really quick. And then below our void update, we're going to write a new void called onTriggerEnter. And below this, we're going to have a quick check of what we're hitting. So other.compareTag player. And what this is doing is, in case the object hits something else like our kill zone or I don't know, a different power-up, a different obstacle, it won't do anything. However, if it hits the player, this will run. And all we're going to do down here is simply reload the scene that we're in. So we can do scene manager dot load scene, and then because we assigned it up here, all we have to do is type in scene plus empty string. Go ahead and save that out, and then we're going to go ahead and open up Unity again. Now the first thing we need to do here is select our player object. Go up to our tags dropdown and select the player tag. Unity auto-generates that whenever you create a new scene, so we don't actually need to worry about making it ourselves. The second thing we need to do is we need to go to our File, Build Settings, and then there's a button here that says Add Open Scenes. Go ahead and click that and you'll see that our game scene now pops up in that little window up above it. After this, we should be ready to go ahead and play it. And you'll see that as soon as we hit the enemy, the scene reloads. And now that we've done that, we can go ahead and next time start working on our score. We're going to go ahead and have it build up over time, and then whenever you hit the green, you'll get a score boost. To summarize what we've accomplished today, we've got our AI moving, we've got our player jumping in depending on wherever you click on the screen, and we've also got it reloading the scene whenever the player dies. Next time, we're going to go ahead and simplify our AI script, and then we're also going to set it up so that way our score begins to work.